This is lecture number 2. We're going to begin doing the climates. We're going to start with the tropical, subtropical climates, climate number 1 through 5 in this lecture. All right, here we're going to spend some time by introducing what we're going to be doing. Now, for each of the 13 climates, we're going to have a graph. It's called a climograph or climate graph that's showing you the two major variables that we average over 30 years to determine the climate of a place. And so what we're going to be looking at monthly data, averages in January through December, right, for various locations on Earth. And so what we've got is here in January, we've got a bar graph. That's going to be representing the precipitation, all right, on average over the last 30 years for each month for this one location representing our first climate. And so we'll be looking at the bar graph, and we'll be looking at the annual total, and we'll be looking at how much precipitation in general that is received each month. And then on the top, we've got a line graph, and that's going to show the averages. Here's each dot representing each month. All right, so January, February, March. And so this is the average temperature, right, for each month. And so what I want to make sure that you understand is, let's say for January, say for January 1st, what they do is they take the high of the day and the low of the day, and then they average that temperature, right, for January 1st. And so you get an average temperature. And then you do the same for January 2nd, the high and the low, and average that. And so you've got 31 numbers, right, and then you average those together. And so this is the average temperature. So it really isn't the high or the low of the day. So the high would probably, be whatever it is, maybe 10 degrees higher or whatever, I don't know. But what it is just like an average. So that really, in reality, is higher or lower. All right. Now, in the middle, we're not really going to look at this so much. It's just reminding you where the subsolar point is in the tropics throughout the year. All right. And so if you remember, at the equator for the equinoxes, the northern hemisphere for our summer solstice, and then winter solstice for us in the southern hemisphere. Okay, so the first climate is called the wet equatorial climate. And as I had mentioned, we're just going to number them for organizational purposes. Now, for each of these world climates, what they've chosen is one weather station to represent, all other locations of this climate. And so here we are in Iquitos, Peru, 3 degrees south latitude near the equator. And so we've got a climograph, representing this world climate. And what we're going to be doing is just making general statements about the temperature and precipitation regime of each climate and why. All right, the mechanism producing the temperature regime and the mechanism producing the precipitation regime. Now, the other thing that I want to say also is always look at the name of the climate. It's telling you, right, what is going on in terms of precipitation and temperature. It's always doing that. And so it's it's called wet equatorial, so it's going to be a very rainy climate, and this is going to be found near the equator. Now, what do you know about temperatures at the equator? So immediately, just by looking at the name, it's telling you it's a hot and rainy climate immediately. All right? Okay, so let's begin. Let's take a look at the temperature regime of this climate. All right, throughout the year, January through summertime, all right, on average is about 80 degrees, all right? And so that is a warm average temperature, right? And so in reality, it's probably in the 90s at least, okay? So anyways, it's warm or hot all year long, and it's very, very humid, just like here in summertime, or even worse. So it's a warm and humid climate. Right. Now, the thing is, there is no annual temperature range, really. If you take a look at it throughout the year, it's just, hot, right? It's hot and humid. And an annual temperature range, it's really nothing. If it's 4 degrees between the coldest month and the warmest month, it's really kind of like a joke. So it's just warm all year long. Now, why is it warm all year long near the equator? You've got high sun angles and basically 12 hours of daylight all year long. All right, and remember that we're at the equator, and so we've got the subsolar point directly overhead 2 times during the year. And then even during the solstices, the sun angles are just off by 23 degrees. So it's high sun angles, long daylight makes warm temperatures. Now, in terms of the precipitation regime, you can see in the bar graphs for each month it's really quite rainy. All right, so it's wet, rainy all year long. All right, so in every month, I mean, you're receiving a minimum of 4 inches, up to on average about 10 inches. So again, over the last 30 years, on average in January they receive, say, like about 10 inches. Okay, and then February about the same. So remember, this is 30 years of data. There's a little bit of a low spot here, but 4 inches of precip is still a lot. All right. Now remember, in Thibodaux, just by comparison, we receive about 65 inches on average per year. And typically, we get maybe 3, 4, 5, 6 inches per month, typically. And so you just kind of compare what we know to, 10 inches or 12 inches. So it's quite a rainy climate. And so when you have a lot of rain, 8 or, 8 or 10 inches of rain, you're going to wind up with a high annual total. So typically the wet equatorial climate usually gets in excess of 100 inches per year. So this one has about 100 on average per year. But it's not uncommon for this climate to have 200 or 300 inches per year on average at other locations. Okay, so why is it so rainy here? All right, well, where are we? All right, we're at the equator, so we're dominated by the equatorial low pressure belt, that warm air rising, all right? And then also near the equator, you may have the intertropical convergence located there. So on top of all that warm air rising, you've got the meeting of the trade winds, again, forcing that warm air to rise, creating extra rainy conditions. And so those are the two mechanisms found near the equator creating all of this precipitation. Now, the form of precipitation is definitely thunderstorms, all right, convectional precip. And I mean, the thunderstorms can start very early in the morning and they can pretty much last all day. So, I mean, there's, of course, there's no fronts in the tropics, or at the equator. I mean, you need the meeting of opposite air masses. So there's no such thing as frontal precipitation or wave cyclones found at all at the equator or in the tropics. Now, of course, you may have the influence of mountains and orographic effect, but it is basically convectional precipitation. All right. Now, the other thing I want to say about the wet equatorial climate, I mean, just kind of take a look at it. It is monotonous. I mean, it's hot and humid, all year long, every day. Thunderstorms, every day of the year. If they don't start in the morning, they start in the afternoon. And so it's hot and humid, all right, and really rainy. So just imagine maybe the rainiest and most humid July we've ever experienced in Thibodaux, all right? And just imagine that every day of the year. All right. So that's the basics of the wet equatorial climate in terms of temperature and precipitation and the mechanisms. Now we've got to do the geography. Where do you find the wet equatorial climate? Now remember, this is climate number 1, all right, and it's illustrated here with the kind of the darker purple. Now they've got a second climate here. This is our next climate that we'll be looking at the same graph. And so you're always going to find the wet equatorial climate along the equator, and I've added the equator here to the world map. All right, and so you can see climate number 1. So it's always near the equator where you've got the equatorial low and intertropical convergence zone. Right. Now some specific locations. I mean, obviously this is the Amazon rainforest, right? This is the Congo rainforest. And here we've got the rainforest of this climate throughout the islands of Southeast Asia. So those are the 3 major world locations where you're going to find the wet equatorial climate. And so what we're going to do is take our model continent, and now we're going to place our first climate on it. And so remember, we're going to start sort of in the middle, maybe slightly south of the middle. Here we've got the equator here, okay? And so what we're going to do is put where you're going to find it. This is pretty much, where we saw the wet equatorial climate on the map and on the previous slide. and pretty much within about 10 degrees north or south, more or less. And so we're putting the name of the climate here astride the equator, as we saw in reality. And here on the left, we're going to put in the mechanism, the dominant pressure belt. All right, we're going to do that, in increments of 30 degrees. So we've got the equatorial low pressure belt dominating near the equator, and the intertropical convergence zone, all right, is also a major influence near the equator. And so in another few slides, we'll put in at 30 degrees the subtropical high, and on and on and on. And we're also going to put in the wind belts too. Right? So you've definitely got to go back, if you don't remember, the global circulation of the atmosphere. All right. Okay, we're going to move on to the second climate. It's called the trade wind coastal climate. Now the name, all right, this climate, all right, is dominated by the trade winds. Now remember the important thing about the trade winds. These are the winds of the tropics. Right? You know that they're the winds of the tropics, and so this is immediately telling you you're in the tropics, so it's going to be warm, and it's also really just a coastal climate within the tropics. All right, and what we've got for our representative location, we're in Central America, all right, in the country of Belize City, all right, and so this is going to be our representative weather station for this entire climate. All right, so we're in the tropics. The trade winds are in the tropics, and so again, throughout the year, it's warm. It's warm. I mean, somewhere around 80 degrees. I mean, so you got an annual temperature range on average of about 9 degrees. It's really not much. And so if you've got an average temperature of 80 or even 75, I mean, that is warm. All right, so it's definitely warm because we're in the tropics all year long with high sun angles. Right, here's the tropics. So you've got high sun angles all year long, and long periods of daylight, creating warm temperatures. All right. Now, it is a rainy climate in terms of precipitation. You can see the bar graphs are pretty high. Now, there is a little bit of a low period here. We're not really going to discuss that right now. We're going to wait to, our next climate to get into the subtropical high. But the reason, what we want to do is give you the reason for the rain or the precipitation. Right, here we're in the northern hemisphere, so it's going to be dominated by the northeast trades. All right, so we're in Central America, and so of course we're in the tropics. Right, the form of precipitation, the mechanism is thunderstorm, so it's going to be convectional precip. Right, and what's going on is kind of like what we know in summer here with the Gulf of Mexico. Pumping in moisture, and then giving rise to afternoon thunderstorms. It's kind of the same thing. You've got the trade wind easterlies coming in off of the tropical oceans and bringing in, warm, moist, unstable air, right? And thunderstorms that can begin in the morning or afternoon. And so that's what we're focusing on. So you wind up with a pretty high annual total. Usually, in the 80s, 90s, 100. In terms of annual total. All right, so even though we do have a little bit of a low spot here, we still wind up with a lot of precipitation. Okay, now this is the trade wind coastal climate. So you're only going to find this climate, right, on east coasts, all right, of continents within the tropics. And so what you've got to do is just think of the direction of the trade winds in the northern hemisphere. And so here we've got, I didn't mention this for the first climate, but they always show you the location of the representative climate station. Here we are in Belize. And here we've got the northeast trade winds, those easterly winds coming on in off the Caribbean, tropical ocean, just pumping in warm, moist air. And that moist air moves on land, heated land, causing the air to rise to dew point and creating thunderstorms, right? And so we're just looking at number 2 right here, okay? Yeah. So our best example, I'm not going to make you know every single location, all right? What we just really want to maybe focus, ones that we know about, maybe closest to the U.S. or something like that. And so, so everyone's gone to well, or maybe you haven't gone to, but you know about the Yucatan Peninsula. People go to Cancun and Cozumel, and so it's pretty close to us. So you may go there sometime in your life, so you'd be aware of that climate and how strong the trade winds are. All right. So some other locations, yeah, in Southeast Asia, where you've also got the northeast trade winds coming on, and here's Vietnam, so it's very, very rainy. Then in the southern hemisphere too, there's some other examples. Here's the island of Madagascar with the southeast trades. There is a little bit of an orographic component here. This kind of white dotted area represents high mountains, but you've got, of course, you're going to have abundant precip on the windward slopes due to the trade winds. And then here in Brazil, southern Brazil, again, you've got the southeast trades coming in, bringing in abundant, tropical moisture. I want to give you another really good example. If you ever go to any of the islands of Hawaii, you are going to notice, all right, the trade winds. They're very, very prominent. I've got an example of the Big Island of Hawaii. With the volcanoes, but definitely, right, you've got this is definitely a trade wind coastal climate on all of the Hawaiian Islands. Here's the capital on the Big Island here, and you can see we're in the northern hemisphere, of course, and the amount of precipitation here in blue. All right, here's 160 inches to 200 inches per year. Here's the maximum, almost 300 inches of precip. So when we're talking about these tropical climates, I mean, I'm not kidding when I say 100, 200, 300, maybe even 400 inches of precip per year. And so you kind of notice that this is definitely a trade wind coastal climate. The East Coast, right, abundant convectional precipitation. And here we've got the same. This is the Big Island. So there are, volcanoes, and we've got the trade winds coming on here dominating. All right. So if you ever go to any of the, let me just kind of show you this. Here's all of the Hawaiian Islands. Here we're on the Big Island of Hawaii here, and here's the capital, Oahu, where Honolulu is. And if you ever go to any of the Hawaiian Islands, you're on the east sides, you are going to feel those trade winds. They are persistent and they are strong, and they are pumping in a lot of moisture. And as I had mentioned, there is actually a bit of the rain shadow effect too, a little bit of orographic influence. So if you ever go to the west sides on the islands, you're going to notice a distinct rain shadow, and almost in desert-like conditions. I mean, it really is kind of like we know with the orographic and rain shadow, it's an all or nothing situation. So if you ever go there, but anyways, classic trade wind coastal climate in our 50th state, really. All right, so what I want to do, okay, is I want to put the tropics in here on our model continent, 23.5 degrees north, 23.5 degrees south. And, we've got overlap here, all right, it doesn't really matter. But anyways, what we want to do now is, I don't have room to put in the name trade wind climate. So this is climate number 2. And I've added in, the trade winds, the northeast trades, the southeast trades, pumping in abundant moisture to the east, right, facing coasts within the tropics, all right? And so this is what we saw in reality, and now we're modeling it on our continent. All right, let's move on to climate number 3. It's called the wet, dry tropical, all right? And again, the name is telling you what we're going to have is a distinctive, very wet or rainy season, a distinctive, very, very dry season, and it's going to be warm because we're in the tropics. All right, so it's pretty much telling you the temperature and precipitation regime. Now with this one, we need to know, when the wet season is and why, and when the dry season is and why. And so that's going to be the important thing about it. Okay, well, let's just get the temperature down. Here we've got our representative climate location in Africa, okay, and 10 degrees north in Timbo, Guinea, all right, in West Africa. All right, so anyways, in this one location representing this whole climate, again, if you've got average temperatures of 70 or 80, it is warm. You're definitely in the tropics. There's no winter, really, in terms of temperature. And again, you've got an annual temperature range of only about 10 degrees. So it's very, very warm all year long, all right, because we're in the tropics, all right, high sun angles and long periods of daylight, all right, you know that. Now, the precipitation is the really important thing about this one climate. Okay, summer is the wet season, all right, and that's when the intertropical convergence zone moves into this latitude range. Now, when I was introducing the intertropical convergence zone with the global circulation of the atmosphere, I was making the point that it's located near the equator. Sometimes it's north of the equator, sometimes it's south of the equator, sometimes it's right at the equator. So the intertropical convergence zone moves, and that's a point that I'm going to make in another slide or so. But here we've got, all right, the wet is in summertime. That is the wet season, all right, probably beginning in May, all right, 6 inches, June, July, August, oh my goodness, maybe 15 inches, September and October. So that's about 6 months, all right, of a lot of precipitation. All right, so it's basically the summer half of the year. And so really during those 6 months, you're getting, the precipitation is 64 inches here, so 60, 70, 80, something like that. And so that's when the intertropical convergence zone moves in. And so that's illustrated here in the icons. All right, now winter is dry, all right, and it's really almost desert-like. I mean, kind of beginning in November, on average in November, just one climate station. Over the last 30 years in November, they receive about 1 inch of precip. And then in December, on average, over the last 30 years, none. 0. All right. January, none. February, none. Okay. March, 1 inch on average over the last 30 years. In April, maybe about 2 inches. Okay. So it's 6 months of heavy rain and 6 months of drought. All right. And that really kind of makes this a very difficult climate. I mean, you're just deluged for 6 months of the year, and then you're dry as a bone for the other 6 months. It's a very, very difficult climate to deal with in Africa. All right. Okay, so let's just take a look where you're going to find it. All right. The location is always going to be found astride the wet equatorial. All right, and so this was the wet equatorial. In South America, if this was the Amazon basin, you're always going to find this climate immediately to the north and immediately to the south of the wet equatorial. So it's astride it. And the same thing in Africa. I think here's Timbo, Guinea, where the weather station is. In Africa, I really think it's kind of underdone. This climate is really very famous in Africa. It's a little bit underdone, I believe. But it's, again, kind of to the north of the Congo Basin and then to the south, all right? And that's just really where the climate, like I said, is most famous because it really makes, it's very, very difficult. I mean, you get tremendous downpours during the summer months. And, the rivers overflow and flood. And then you've got, basins that turn into lakes and swamps and marshes, and that forms a breeding ground for mosquitoes and the tsetse fly and tropical diseases, right, that we don't really know of in the United States. And so, and then once that is over, then you've got drought for 6 months, right? So trying to grow crops and live in this environment is very, very difficult. And so it's very, very common. And then there are some areas here in Asia. But basically what we're going to say, there are large areas of this climate in tropical South America and tropical Africa in particular, where it really is most famous. All right. So what we're ready to do now, all right, is show you the location of the wet, dry tropical climate. We find it astride the wet equatorial. So that's what we're doing now. All right. So what we're going to do is just draw in a line, all right, finishing off the tropics. All right, finishing off the tropics and showing you on our model continent the reality that we just saw. The distribution geographically of this climate. Now we're also ready to put in our next pressure belt at 30 degrees. And so this is the subtropical high. Remember, this is how we abbreviate it. The subtropical high dominates, all right, around 30 degrees north and south. All right. So you take a look at the geographical location of this climate, and you see that it's located between two very opposite weather makers, right? Here at the equator, one of the wettest, rainiest weather makers on Earth, and then the desert maker, all right? So obviously, what's going on at these latitude locations, the subtropical high must come into this area and create desert-like conditions during the winter, and then in summertime, the equatorial low or intertropical convergence must come in and bring in abundant precipitation during the summer months. And so I'm going to make a statement now that I hope it doesn't upset you too much, okay? But this explains the shifting pressure belts, right? Now, we had made the pressure belts in 30-degree increments, all right? But in reality, the pressure belts do move, right, during the year. And so they're not always exactly at the equator, always exactly at 30 degrees, always exactly at 60, right? They actually migrate several degrees of latitude. And these pressure belts migrate with the subsolar point. And so in reality, when the subsolar point is at the equator, right, on both equinoxes, that model is the reality, all right? But the problem is, all right, during the winter and summer seasons, when you've got the subsolar point migrating away from the equator, all right, that's when the pressure belts are going to shift, all right? And so then our model, is a bit off. So you think about the shifting northward of the subsolar point during the summer months for us in the northern hemisphere. And so the subsolar point is at 23.5 degrees north latitude, all right? And so all the pressure belts are going to shift north. So the intertropical convergence zone is going to shift northward. Subtropical high is going to shift northward. All of these pressure belts shift northward. Then in the opposite season, 6 months later, when the subsolar point is 23.5 degrees south, that intertropical convergence zone and the equatorial low all shift southward, all right? And so that's what you've got to kind of think of for this one climate. That's what kind of maybe makes this one climate a little bit more difficult, all right? But so what I've done here is I want to try to illustrate this. So these pressure belts do migrate. Now, not all of the climates are really definitely influenced by the shifting pressure belts, but this one is, all right? This one is what you have to know of. And there'll be a few others where you have to consider the shifting pressure belts. So let's just kind of take a look at the northern hemisphere location of this climate and see, let's just think of the shifting pressure belts. All right, now during summer, all right, the subsolar point now is in the northern hemisphere. So what's going to happen is the equatorial low intertropical convergence zone is going to move northward. And summer is the rainy season for this climate, all right? And then we're going to have the fall equinox, so our model is perfect. Then we're going to have winter time. And all the pressure belts are going to shift southward. So the equatorial low and intertropical convergence zone are going to move southward. And we're looking at this one location in the northern hemisphere. The subtropical high is going to move in, bringing desert-like conditions for those 6 months, bringing, no precipitation. And so you just kind of take a look at the geographical location or the latitude location, and you can obviously see that these are dominated by these two opposite pressure belts that shift seasonally. Now, it works for the southern hemisphere too. I mean, if you shifted everything, southward in wintertime and northward in summertime, you just got to remember that the seasons are reversed in the southern hemisphere. That's why, I did the northern hemisphere one for you, because you're more familiar with that. All right. Okay, we're going to move on to the fourth climate. It's called the dry tropical climate. Dry tropical climate. And what we're going to do is we're going to compare, when you're studying, you're going to compare this climate to the next one. All right, climate number 5. Okay. Here we are in Sudan. This is our weather station in Wadi Halfa in Africa, all right, in the Sahara Desert, actually. And if you just kind of saw where we were on our hypothetical continent, we had just finished out the climates for the tropics. So we're right on the fringe of the tropics. We're kind of moving, out of the tropics. And so what we're going to wind up having is a winter season where sun angles, all right, are going to be lower. All right, so if you're moving, here we are in the northern hemisphere in winter time. Northern hemisphere. Think about winter time. The subsolar point is now getting a bit farther in the southern hemisphere, so we're going to have lower sun angles and a little bit shorter periods of daylight. And so this, for the first time, we're picking up an annual temperature range. All right, and so we're going to wind up with lower sun angles during the winter months in the northern hemisphere here, where the subsolar point is now pretty far away in the southern hemisphere during the winter months. So we're going to have lower sun angles and cooler temperatures. So this is the first climate where we pick up an annual cycle since we're out of the tropics. All right. Okay. And so the annual cycle, annual temperature range is about 30 degrees. All right. So that's really okay. Then the other thing about this climate is there's no precipitation. Right. And so in the Sahara Desert here in Wadi Halfa, on average over the last 30 years, there was absolutely no precipitation. All right. And so, look at this, it's crazy. The annual total on average over the last 30 years is less than 1/10 of an inch. Okay. So what we say is precipitation is rare. All right. And so here we are, at about 30 degrees, north latitude at this one location. And this is where we have, even though there is the shifting of the pressure belts, here you've either got the subtropical high, directly overhead, or, if it's shifting south, you're still kind of under the influence. If you're shifting north, you're still under the influence of a portion of it. So it really is the total dominance of the subtropical high throughout the year. It's total drought. Okay. All right, so we're going to have a whole series of desert climates, okay? And this is our dry or desert climate map. And so it's showing you our 3 desert climates, right? We're on climate number 4, okay? Then we're going to be doing climate number 5, and then in another lecture, we'll be doing climate number 9, so we'll be seeing this map again, all right? And so we'll be seeing it 2 more times, showing you. So what you've got to look for this climate is where climate number 4 is, okay? Climate number 4. All right, for each one of these. And then in the southern hemisphere, climate number 4, climate number 4. It's the dry tropical. All right. So another thing that we need to make a point of too, it's not well visualized right now. All right, but as we move along with some other climates, you will see this. All right, it's very important to note that the dry tropical and really and the dry subtropical, the next one we're going to do, are pretty much found on west sides of continents near the tropics, west sides. All right, and so just kind of take a look here for North America. All of these dry climates pretty much are on the west side of North America. Now, it's a bit hard to see here, but we're just kind of looking at climate number 4, and we'll be looking at climate number 5, which is very similar. And if you kind of take a look at Africa and Asia, they're 2 continents actually, but they're attached. People don't realize that continents can be attached. So it's just really one land mass. And if you kind of take this one giant land mass and look at climate number 4 and the next one, climate number 5, it really is on the west side of this giant mass of Africa and Asia. And even if you want to include climate number 9, which is another dry climate, it still pretty much is making, dry for the west. And we've got all these other rainy climates here that we're going to see on the east. All right. In the southern hemisphere, Australia is definitely a dry climate. And we're actually going to find, even though it's dominated by dry or desert climates, we're going to find really quite a rainy climate on the east side. All right, so definitely major deserts of the world. And I just kind of want to make a point, of a good example close to us. All right, so here's the tropics. Okay, we're dominated by the subtropical high here. Basically, our closest example is the country of Mexico. And it's it's a dry dry climate, climate number 4, and the H here is for highlands. Basically, it's a mountainous desert near the tropics. And so here we've got the Sahara and Arabian deserts, okay? And so here's climate number 4, closest to the tropics, all right? And the same thing in the southern hemisphere for Australia. Here's the Tropic of Capricorn here, all right? And here's this dry tropical climate. So let's put it on in. And so what we want to do is show kind of the western tendency for dry climates. So we're going to put the dry tropical to about 30 degrees, all right, so we're still, so in terms of temperature then, you got to just kind of remember that, say, if this is Mexico, all right, what's going to wind up happening during the winter months is, the subsolar point now is pretty far away, and we're going to have lower sun angles, making kind of a mild season, all right? It's not freezing cold, but it's mild and tolerable. Okay, and so we're going to finish up the climates here, and what's going to be kind of nice with the dry subtropical, right, is that we're actually finally in the United States. And so now you can kind of think about what you know about the United States. So the climate number 4 was the dry tropical. Climate number 5 is the dry subtropical. And so you're always going to find this climate poleward, all right, of the dry tropical, of the last one. Poleward means a higher latitude location, all right? And so if Mexico was a good example of our last climate, well, let's just go north of Mexico into the United States, and we're going to find this climate in the deserts of the southwest of the U.S., and here we are indeed in Arizona. All right, and so what you need to know is, since we're at a higher latitude location, all right, winters are going to be a little bit cooler, all right? Summers are very, very hot, all right, in the desert, and we wind up with a larger annual temperature range, and that's what you need to know. All right, the annual temperature range for Wadi Halfa was, I think, 29 degrees, and so we got a larger annual temperature range because now we're at a higher latitude location, and we're farther away from the subsolar point in wintertime, and so sun angles are going to be a little bit lower and a little bit shorter periods of daylight, and we're going to get a little bit cooler, all right? But actually, it's a mild season. So in terms of the temperature regime, it's a larger annual temperature range than the dry tropical due to the higher latitude location. And again, precipitation is very low. We're still dominated by the subtropical high. Again, there are some climates where we really don't have to worry about the shifting pressure belts. And so in Arizona here, the annual total, look at this, all right, on average in Yuma, Arizona, 3 inches of precipitation per year. My God, I mean, we can get that. Well, we do. I mean, we can get 3 inches in a day or in an afternoon in a thunderstorm here. And so in Arizona, I mean, I know, in January, they might get a little tiny bit of frontal precip, maybe a cold front or a warm front might move through, bring a little bit of rain in the winter months. And then maybe some moisture might come in from the tropical Pacific or even the Gulf of Mexico, bringing a little bit of thunderstorm activity, all right? But still, okay, definitely the dominance of the subtropical high. So the precipitation is still very, very low in a classic desert climate. All right, and so what you're going to do is study these two together, and so the precipitation is very low, and we're just getting to a higher latitude location again with a larger annual temperature range. So that's pretty much what you need to know. All right, and so in terms of the location, here we are back with a dry climate map, and you just got to look for climate number 5, all right, higher latitude location. And again, here, this mountainous desert here, all right, mountainous desert. Here's the deserts of the southwest U.S. here. And so from now on, we're going to be, like I said, I want you to think about the United States and always know your U.S. examples. All right, for the test, always know your U.S. examples. And so here we are in the southwest U.S., okay? Even take a look at Sahara and Arabian deserts. Here's climate number 5. We're higher latitude location. And so here along the Mediterranean, winters, and this is where all the big cities are, of course, the winters are milder, okay, as opposed to being close to the tropics. So a little bit cooler winter times, really kind of nice weather here. Then think about it in Australia, right? And so here we are at the Tropic of Capricorn. So, winters, are a little bit warmer than they are a little bit higher latitude location. And so here's the subtropical, just out of the tropics, okay? And so as you get closer to, say, well, Antarctica, okay? And so still dry, but as you get to higher latitude location, winters are a bit cooler, all right, as you get lower sun angles. All right, so let's kind of put it on in, all right? And so let's just say maybe let's go to about 35 degrees north and south and still show the dominance of the subtropical high, even though it is moving. You're either on the northern or southern edge or it's directly overhead, on the equinoxes. And so we'll put in our dry subtropical, all right? End lecture.